Hi, it's Mrs. Moss here, and today we're going to be talking about hotspots. But we're not talking about hot heat energy from the sun. No, we don't need our shades quite yet. We're talking about energy that comes from well below the Earth's surface. So what exactly are hotspots? Well, they're places on the Earth's surface where plumes of magma are rising up from the mantle, not located along the moving plate boundaries or the active plate margins. And they're associated with volcanoes, not with earthquakes. Let's look at an animation to show how a hotspot forms underneath the Earth's crust. Starting this off, we see that there is a level here of magma well below the Earth's surface. And you see too at this end result, here is the stream of lava that comes up, pushes its way through the Earth's surface and forms a volcano. Let's look at the beginning part of this video, and you can see how exactly this happens. Watch closely as the plume and the magma force its way upwards to the Earth's surface, creating a volcano. There's the volcano. Now, what's happening here is that although the hotspot is in the same location, the Earth's plate, the crust that's at the top, is moving. So what you're going to see here is as the plate moves, that hotspot stays in the same position, and eventually that magma will break. It'll break that flow. So then the volcano will actually become inactive. Let's watch. So it's remaining active. Boom, it just broke. But if you notice, that stream of lava still is occurring. So this hotspot remains. And even though the plate has shifted, it's going to create a new volcano because that magma is still going to come up from the hotspot. A new volcano is forming in that hotspot. Boom, it breaks. And those two volcanoes are inactive. They will eventually fall below the sea level and become seamounts. But here we have an island now, and we'll see as we go further in our discussion, you'll see some examples of this. So this is actually how we form the islands of Hawaii. And you notice here in this picture we have the plume coming underneath the newest island, which is the Big Island of Hawaii. As this magma has broken off and the plates have shifted, we've had other islands that formed. As you go away from the hotspot, each of these islands become progressively older. Sound familiar? Kind of reminds me of the divergent plate boundaries, how the new magma is constantly coming up. But notice, this is not occurring along a plate boundary. This is just like a random pocket of magma that comes up and bursts through the Earth's surface. And here's another diagram. You can see in this picture, I like this one because it shows the actual plate moving across the top, but the fixed hotspot stays in that position. You also see that the Big Island of Hawaii, is considered the youngest, and actually it's still an active volcano today. The magma is still coming up and it is still erupting. But the other islands that were formed from this hotspot are remaining there. Another picture of the beautiful islands of Hawaii. Notice Kauai would be considered the oldest island because it's farther away from the hotspot, which is located here at the Big Island of Hawaii. And this is just another diagram showing you that the farther away from the hotspot, the older the islands. From studying the location of the islands, we can figure out what direction the plate is moving. So in this picture, we see a picture of the islands. Because the Big Island of Hawaii is up in this corner in this diagram, we know that the plate let's go back. We know that the plate had to have been moving in that direction. So let's pull out our reference table. Go back to the page that we studied with Earth Science Reference Table Tectonic Plates, page 5. How many hotspots can you count? Well, let's see. Take a moment and circle as many as you can. Hit pause before I give away the answers. All right, we've got 1 here, 2, 3, 4, 5, 6, 7, 8, 9. How many did you get? So that ends our plate tectonics discussion. Hope you enjoyed the hotspots video. See you next time.